Welcome to Enots Engineering. I'm Alan. In today's video we're looking at setting the compound slide. So here are a few tips on how to set the compound angle to the correct degrees. So let's go to the workshop, see how we do it. On my lathe, the compound slide, the angles are very close together, and anything less than a degree you're really just guessing. I want to set my angle to a number 2 Morse taper. So the first way is to get something that already has a number 2 Morse taper, and in this case what I want to use is this, my die holder guide, but that will fit in the chuck. It has a plain diameter with a number 2 Morse taper on the end, and that gives me an angle that I can set my compound slide to. What I want to do first is check that my dial indicator is set to centre line. This is my tool centering gauge. As long as that ball on the end is on centre line, just come up just a little bit. I'm just setting it by eye. Now that's on centre line now. Lock that up. Now I've set the taper roughly. I put a dial indicator on the taper that I'm checking. So if I wind that in, so there. Let's just adjust that taper a bit more. Lock that up. Reset it to 0. Each division on here is 1/10 of a thou. I'm going to leave it at that, just less than a thou. That Morse taper angle should be 1.4307 degrees. Now to find the angle, you can go onto the internet and type in number 2 Morse taper angle, and it'll bring up the angle. Now that's the first way of setting your compound slide. The next way is to use a sine bar on your compound slide. I've removed the tool post. Now to use the sine bar, you must have a flat surface that's parallel to the axis. This one I machined on both sides. It was just rough casting painted, and I'll put the link to a video to see how you can do that if you've just got a rough casting. But you need a flat face to set the angle. This is my sine bar for the compound slide. It consists of 2 pieces of silver steel pressed into holes. The distance between the 2 holes is 75 millimeters. So I therefore know that's one side of my triangle. I know the angle, so I can work out what I need to put under one of these diameters to give me 1.43 degrees. Under these caps here are magnets, and what I did was I embedded them in the aluminium to make it easier to clean any swarf off them. And that just goes on the top, it holds it in position. And on the machined edge, I've got this edge machined on each side. So all I need to do then is to work out the distance I need to put under one of these dowels, which is this one, to hold it at 1.43 degrees. Push it to the machine face, Now on the one side, to get the 1.4 angle, I think it's 75 thou. So 75 thou in slip gauges you can't do, but I can do 0.17 and a 0.105, which is 0.275, so I'm on 0.2 up. And on the other side I just put 0.2. You can see the magnets hold it firm enough. The slip gauges are held by the magnet, but they also rest on this little ledge on the edge. So now if you look at the dial indicator, as I go along, we're talking about 0, just over 4 thou on that length. The usual way to do it is just do it by eye to the graduations on the compound slide. And if you have a digital readout, you may be able to use that to calculate the angle. I've set my dial indicator on the machined face of the compound slide, and I've zeroed it at this end. 0, 0. Make sure you're on 0, 0. Press the triangle with the, looks like a milling cutter on it, and it asks you some questions. I'm working on XY axis, that's okay, enter, and I've put the angle in. Now if you're having problems you might need to put a minus in. It depends which way your compound slide's facing, away or towards the centre of the lathe. Once you've put the angle in, press enter, move down. Now it's asking me to move my X and Y, so I'll move X, I'll back this off, move along the other end, go back into 0, once I've done that I press Y and it's telling me the angle is 0.2 of a thou out of position. I'm not worried about 0.2 over 5 inches. So when you finish, just press the angle again, zero your positions, and that takes you back to your normal startup. And the final way, which you can produce a taper, but now not using the compound slide, on this Boxford I have a screw on this side and a screw on the other side, and by tightening or loosening one or the other it will move the tailstock in or out. You can see it's on a slide here, so you can move that tailstock in or out, and that way you can actually turn something between centres and turn a taper by offsetting the tailstock. Oh well, that's it for today. Thanks for watching. Hope you enjoyed it, and we'll see you next time on Enots Engineering.